Now, for our synthesis question, as always, we want to approach these retrosynthetically. And the first thing we should start thinking about in a question like this, especially because this is an aromatic question, is the groups that we have, are they orthopara or are they metadirectors? Because as we can see, we clearly have three different groups that are all metadirectors. That are meta to each other, but only one of them, the ester group, is actually a metadirector. And so that suggests to me that that's the group I want to get on first. And so at some point along the synthesis, I'm going to want to get to that compound. So now I've made this problem into two smaller problems. One is that I need to get from my final product back to this compound, the ester. And the second piece is I need to figure out how to make this ester from benzene. Well, I know I can make an ester if I have a carboxylic acid. That's the Fischer esterification. And then we've learned a couple different ways to make benzoic acid from benzene. So I'm going to go for the easy one, which is to make bromobenzene and then use a Grignard to make the carboxylic acid. Now, how do we get the rest of this? Well, a chlorine is a group that I can put directly onto an aromatic ring. But an amine is not. An amine generally comes from a nitro group. Now, if I make this compound from a nitro group, the first thing is we know that this ester that's already here will direct that new nitro group meta. But even more useful is the fact that I now have a pair of meta groups, and so if I try and put the chlorine on right now, the only position it can go is right here. All right, so now I'm happy with how I've planned this, and it's just really a matter of mapping out our forward synthesis. So starting with benzene, I can do a bromination. I can then convert bromobenzene using a Grignard reagent, followed by dry ice, to make the carboxylic acid. The carboxylic acid can undergo a Fischer esterification using isopropyl alcohol to give us our desired ester. That ester can undergo a nitration reaction. Now, I need to at some point reduce the ester because what I have in the product is an amine. But I don't want to do that yet, because right now I have a nitro group which is a metadirector, and that's going to help us. If I make this nitro group into an amine, it becomes an orthopara director, and I have our two groups working against each other. So therefore, I'm going to do the chlorination first. That way we know the chlorine will go on exactly where we want it. And then finally, I can reduce the nitro group using hydrogenation conditions. And that will give us the final product.